because you're going to be using this stuff again today. So right here, you have to notice, okay, this is arithmetic, meaning there's a common difference. Our -4 minus -2 is -2, -2, -2. Does everybody understand? So because there's a common difference, it's arithmetic, and you've used the formula a sub n is equal to a sub 1 plus n minus 1 times by the common difference. A sub 1 is the first term, which is 2, plus n minus 1 times -2. Then, because if I ask you for the formula, you're going to want to give me the answer for the simplified formula, which many of you didn't do, but on the test you're going to want to. So distribute -2 through, so that's -2n plus 2, isn't it? So then our simplified formula should have been -2n plus 4. I don't know if I saw anybody with that, did I? Oh, okay, awesome. Okay, so a sub n is equal to -2 is equal to -2n plus 4. That would be our explicit formula. Now find the 84th term. A sub 84 is equal to -2 times 84 plus 4. What did you get? -164. Okay, good. Do we have any questions? Because you're going to have to be able to continue to do that. Okay. Now down here you would have to recognize, okay, there's not a common difference, which is what Lydia said. That is true. So then is it geometric? That's the next thing we check. So we would divide. 48 divided by -12 is -4. -12 divided by 3 is -4. So this one has a common ratio. So then we would use the explicit formula for geometric, which is a sub n is equal to a sub 1 times by the common ratio raised to the n minus 1. So a sub n is equal to a sub 1 is 3. Our common ratio is -4 raised to the n minus 1. That doesn't simplify because we would not put 3 in. That would be bad. So now we can find the 12th term. So that would be a sub 12 is equal to 3 times -4 to the 12 minus 1, wouldn't it be? Okay, I'm just going to put 11. Now you would type it in, and we get, anyone? -2. All right, any questions? How many of you got both right? A lot of you did. Very good. Awesome job, you guys. Good. Okay, let's get to today's lesson. You're going to want to take a few notes. This is where it gets a little bit more difficult, not so straightforward. Like the other lessons were just so very straightforward. However, it's not super bad, especially if you pay attention to the little details I tell you. Okay, so a sequence is just a sequence of numbers. We know that an arithmetic sequence, we can take and write the explicit formula, which allows us to find any term in the sequence, correct? Arithmetic means there's a common difference. Today we're going to focus in on an arithmetic series. Now, a series is adding up the sequence of numbers. So look right here. An arithmetic sequence, there's a common difference of 2 here, correct? This is a sequence of numbers. Now, this makes it a series. Now, instead of just commas, we're actually summing them up. We're adding up all of those terms. So it's arithmetic because 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2. But now we're going to sum them up, actually find sums. Series means sum. Any questions on that? Okay, so notice on your formulas worksheet, you have this formula. So if you have a finite arithmetic series, finite means, this is very important, finite means you know the start and end. So everybody, 3 plus 5 plus 7 plus 9. Do you see how I know exactly where I'm starting to add? Yes? And we know where the end is. That's considered finite, meaning you know the start and end, so you know where to start adding and when to stop adding. We can find the sum of finite arithmetic series. However, if you have an infinite arithmetic series, so look, 3 plus 5, we do know the starting point, plus 7 plus 9 plus ... That means we're just going to keep adding forever, which could we even find a sum? Well, no, because think about it. It's just going to continue to get larger and larger. So we're just going to keep adding forever and never know when to stop adding. Does everybody understand? So because it's infinite, we can't find a sum. Everybody good? That's true for arithmetic series. If you do not know the end, you have no idea where to stop adding, so you can't find a sum. All right, but if you do know the start and end, if it's finite, then you can find the sum using this formula. So S of n, so this means we're summing up this many terms. So n is the number of terms we're summing up. That's the notation is what throws people off here, so everybody pay attention to that. So S of n means we're summing up, if this is a 10, we're summing up 10 terms. Does that make sense, everybody? So look up here, 1, 2, 3, 4. We would be summing up 4 terms. Everybody understand? So we plug in 4 there. A sub 1 is the first term in the sequence, so we would put a 3 in. A sub n is the last term in the sequence, so we would put in 9. And then we would just plug it into the formula. So with this one, for example, wouldn't it be easier just to actually add them up by calculator? 3 plus 5 plus 7 plus 9? Yes. But it won't always be easier to do it that way. So let's do it that way let's do it by that. Real quick, on your calculator, type in 3 plus 5 plus 7 plus 9. What do you get? You get 24. Okay, so that equals 24. Let's do it using the formula. So 1, 2, 3, 4 terms. So we're summing up 4 terms, which is equal to n is 4, so 4 divided by 2. I'm showing you how to plug it into the formula. A sub 1 is the first term in the sequence, which is 3 plus a sub n. We're going to be doing a sub 4, which is this. Does everybody understand the last term in the sequence? Plus 9. So now type that into your calculator. Well, first of all, we could do this. What's 4 divided by 2? 2, 9, 10, 11, 12. This is first term means not a sub 1 just means the first term. Do you see how it's 3? Look right here. This is a sub 1. Does that make sense? That doesn't mean you have a 1 there. A sub 1, remember, means first term. Oh, yeah, this was just a totally different example. This wasn't on the homework, yes. That's in the formula. Yeah, good question. Good questions. So then do you see how we got the same thing using the formula? Okay, awesome. Okay, so that would be the formula to find the sum of an arithmetic series. It is not the same formula for geometric, so just keep that in mind. Okay, let's do this example. Find the sum of the arithmetic series. Is this a problem on your homework? Yes, number 1. I don't know why I didn't write number 1. Oh, no. It's not. Okay, awesome. Then just watch. Just watch, okay? So, that's the one we just did, isn't it? Pretty much. Okay, let's just use the formula for kicks and giggles. First of all, how many terms am I summing up? 1, 2, 3, 4, 5, right? So I go like this. S of 5, that means we're summing up 5 terms, is equal to 5 divided by 2 times by the first term, which is 3, plus the last term, which is 11. Type it into your calculator. That's all you got to do. So the sum of those 5 terms was, what was it? 35. Perfect, 35. Let me grab. Notice in this example, we have 2, 4, 6, plus dot, 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 plus 100. We know this is a sub 1, this is a sub 2, a sub 3. Now, isn't this a sub n, our last term? We've got to figure out what term that is. Does everybody understand? This is where it gets a little bit harder. We're going to have to just think a little bit. So everybody, do you understand? To find the sum of this, we need to know how many terms we're summing up. This is the last term. So this is how you do it. Think about it. Take your calculator and do 100. So we got from 2 to 100. How much distance is that? Or you can just think about it. 98. Isn't there a distance of 98 between 2 and 100, everybody? But now we're not splitting ones. That would be adding 1 each time, correct? What are we adding each time? 2. So we've got to split that up. We didn't go 98 places to get to 100. Does everybody understand? We divided it by 2, 49. Now understand, that means we took 2 and we added 2 49 times. Does everybody understand? There's not 49 terms though, there's 50. Here's why. That doesn't account for the first term. So it took us adding 2 49 times. That put us to 100. So how many terms? You got to add 1 more to that to get to the because that doesn't account for the first term. Yes. Yes. Yeah. Yes. Yeah, but what if we would have started at 6? Does that make sense? Yeah. So what if we would have started at 6? That's why we always will do this every time, because otherwise it gets like, well, how many did I add? Does that make sense? So guys, let me say it one more time, and to make it make sense. We need to know how many terms we have in here. We are going 2, 4, 6, 8, right? Once again. So if we were working in ones, there's a distance between 2 and 100 of 98. But we weren't working in ones, we were working in twos. So we divide that by 2, and that means 49. So we added 2 49 times to get to 100. But that's starting with 2. So we have to say, okay, but we also have to add a 2 with it, our first term. So we're going to be summing up 50 terms. So you'll always do that and then add 1. So we're summing 50 terms. Here we go, let's plug it in. So 50 divided by 2 times by a sub 1, the first term, which is 2, plus the last term, which is 100. And then you can just type it in. Go. So type it into your calculator. The sum of 50 terms, of those 50 terms, retype it in. We should get this. Okay, 2,550. Okay, awesome. Any questions on that? Okay, we'll do a few more, and then maybe we'll click better. Okay, here we go. Let's do this one. 4 plus 9 plus 14 plus 19 plus 24 plus ... plus 99. So you say this is a sub 1. I need to know, and we know a sub n, but we don't know how many terms is between there. So let's figure out the distance between 4 and 99. So take your calculator and do 99 minus 4. What is it? Okay, 95, everybody. I guess we can just think. Sorry. I always just tend to think about the harder stuff and then don't even think about what I'm saying. So guys, we have 95, but that is moving in ones, correct? We're not moving in ones. What are we moving in? We're adding 5 each time. So we weren't dividing it by 1. We're dividing it over intervals of 5. So take 95 divided by 5. 19. So we added 5 19 times to get to 99. So there's more than 19 terms, though. We have to account for this term, which is 20 terms. Does everybody understand? Okay. Sum of 20 terms is equal to 20 divided by 2 times by a sub 1, which is 4, plus a sub n, which is 99. And now you'll just type it into your calculator, and you should get 1,030. Is anyone confused? Feeling good? Okay. Let's do one more, and then I'll let you do 1 through 7. Let's just make sure we're good with negatives. So we're going -3 plus -6 plus -9. Let's figure out first the common difference. -9 minus -6. And then -6 minus -3. -3. Everybody understand? So we're subtracting 3 each time, right? So it's arithmetic. So then you'd say, okay, this is a sub 1. This is a sub n. Well, let's figure out the distance here. So take your calculator, do -30 minus -3. What is it? -27. Now, that would be working in ones, though. We're working in intervals of, so divided by -3. So it's 9. That means we're summing up how many terms? 10. Good. The sum of 10 terms is equal to 10 divided by 2 times a sub 1, which is -3, plus a sub n, which is -30. And you would literally just type it into your calculator. So the sum of those 10 terms equals -165. Questions? All good? Ready to do 1 through 7? Okay, awesome. 1 through 7, check them off with me. Ready, set, go. I'm going to explain this one more time. If you're still a little confused on the first part, figuring out how many terms, watch this one. So I'm explaining it in very basic terms here. So to get from 4 to 12, there's a distance of 12, 11, 10, 9, 8. There's a distance of 8, but we're not adding 1, we're adding 2. So that's split over intervals of 2. So that would be 4. Now that means we added 2, 1, 2, 3, 4 times to get to 12. Does that make sense? But that does not account for summing up. Notice what's missing. I didn't underline it because starting with 4, I added 2 4 times. Does that make sense? So now I have to say, but I also am summing up my first term. So I got to add 1 to that. That's why we do that, adding one thing, 5. Okay, so here is summation notation. Pay attention because this is where people start to get a little confused and it's not any harder. But you can get confused in what it's saying. So summation notation literally just means find the sum. So you might see them asking you to find the sum, like we were just doing, by using the Greek capital letter sigma. So this literally just means find the sum. It's a summation sign. So just like what we were doing, it's just not writing out the plus signs, it's saying it in like a shorter way. So write this down somewhere, maybe on the back of your formula sheet. So this is going to be the form you're going to see it in, which it literally just means exactly what we just did. So it's going to have a sum sign, that means take the sum, and then they're going to tell you where to start. So our lower, it's going to be called our lower limit. So notice right down here it's 1, and right down here it's 3 in this example. And then we have our upper limit, which means where you're stopping. So notice this one's 4. In this example, this one's 5. Then right here is going to be the explicit formula. Remember what an explicit formula does. It allows you to find all terms in a sequence. And for arithmetic, it'll have this form. So there's going to be an explicit formula, which is what you plug in to find any term in a sequence. Correct, everybody? Okay, anybody confused? Okay, so now we're going to take that knowledge and we're going to find the sum. So everybody look at this example with me. Is this one on your, yes. Oh no, this one's not. Okay, so just look, because I don't want to take any away from you. What this means is find the sum. That's all it says. Now, here's our explicit formula. Our lower limit's 1, our upper limit's 4. So what you can do is write out all the terms if you want. So let's plug in 1, because do you see how that's my lower limit? We're summing up the first through 4th terms. Does everybody understand? I'm going to say that again and watch. Look. We are summing up in this one the first through the 4th term. How many terms would we be summing up? 4. Does that make sense, everybody? So how did we, okay, so let's plug in 1 here. So plugging in 1, because it's our lower limit's not 1, it's 1 plus 2. Does everybody understand? Yeah. What is that? 1 plus 2? 3. Awesome. Now let's plug in 2. 2 plus 3 is 5. Plug in 3. 3 plus 5 is 7. Sorry, I didn't mean to say that. 3 plus 2 is what I meant to say, sorry. Because we're plugging it in here, my fault, right? Does everybody understand? I'm just plugging in 3. Yeah, are we just adding 2 each time, guys? Okay, so 7, 8, 9. We plug in 3. We did 3 plus 2, which is 5. Wait. What did I mess up on? So we plugged in a 1. 1 plus 2 is, plug in a 2. 4. Plug in a 3. Does everybody understand? Plug in a 4. 6. Okay, this is what our sequence looks like. Plug in a 4, 5, 6. That's what we ended. Does everybody understand? This is the explicit formula that generates this sequence. Everybody good? Sorry, I confused everybody a second ago. Okay, awesome. So now, this must be a sub 1. This is a sub n, correct? Everybody understand? We're summing up 4 terms, right? So just use your formula. The sum of 4 terms is equal to n, which is 4, divided by 2, times by a sub 1, which is 3, plus a sub n, which is 6. So now let's type it in. So, what do you get? Awesome. It is 18. So it was 18. The sum was 18. Does everybody understand? Now, we didn't have to list out that or that, did we? We only needed the first term and then the last term. Does everybody understand? So let's look at this one and just do it the easiest way possible. So you say, this is telling me to find a sum. I need the first term. Let's find a sub 1. So isn't my lower limit 3? So that means we're summing up the 3rd through the 5th term. Not 1. We can start at different things. Does that make sense? So we plug in 3. 3 minus 1 is 2. Let's find a sub n. The last term, which would be plugging in 5. 5 minus 1 is 4. Now, how many terms are we summing up? Don't say 5. That would be wrong. The 3rd through the 5th, correct? 3rd, 4th, 5th. You see how that would be plugging in 3. So this is how we could find it. What's 5 minus 3? 2. There's a distance of 2, but then we have to add 1 to account for the first term. Does everybody see how we're summing up 3 terms? Third, fourth, and fifth term. That's 3 terms. No one's confused? Okay, so you'd say the sum of 3 terms is equal to 3 divided by 2 times by a sub 1, which is 2, plus a sub n, which is 4. And then you plug it in. We plug it in to the explicit formula to figure out what the term is. So what was the sum of those 3 terms? What is it? 9. Cool. Are we confused? Okay, I'm going to do another one. So let's look up here. This means find the sum. Are we summing up the first or 10th term? How many terms does that mean we're summing up? 10. Because you're plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would put us at 10. Does that make sense? 10 minus 1 is 9. Then you add 1 more. So 10. Is everybody good? So we're summing up 10 terms, which is equal to 10 divided by 2 times a sub 1. A sub 1, we've got to plug in our lower limit, the lowest thing. 3 times 1 is 3. 3 minus 4 is negative 1. Does everybody see how a sub 1 is negative 1? And then a sub n is 10 times 3 is 30, minus 4 is 26, so you do plus 26. So that's the last term in the sequence. So then you would put that in your calculator. We should get 125. Okay, let's do one off the worksheet. How about? Last example coming off your worksheet. Here we go. Number 16. So it says find the sum. So my question is, how many terms are we summing up here? Well, look at our lower limit. We're plugging in 3. We're starting at the third term. Third term, we're plugging in through 8. So, yep, it's 6. Does everybody understand why? 8 minus 3 is 5. That doesn't account for plugging in 3. So that would be 6 terms. We're adding 1. So the sum of 6 terms is equal to 6 divided by 2 times a sub 1, which means the first term, which that's plugging in a 3, 28. So this will be 28 plus a sub n, which means the last term, plugging in 8. 25, 26, 27, 28, 29, 30, 31, 32, 33. So plus 33. So that's 183. Are we all good? Now once again, why am I summing up 6 terms? Because look, everybody, once again, I'm going to say it one more time. We plugged in a 3 and got something out. We plugged in a 4, got something out. Plugged in a 5, got something out. Plugged in a 6, got something out. Plugged in a 7, got something out. Plugged in an 8, got something out. That's summing up 1, 2, 3, 4, 5, 6 terms. Does everybody see why? Okay, go for it. So now we have to be able to go backwards. It says write each arithmetic series in summation notation. Because remember, they mean the same thing, right? This is just saying find the sum. Isn't this just saying find the sum? Yes, it's just writing it in. They mean the same thing. So does that make sense? Just different ways of writing it. Yeah. So, but that's why, like, we don't want to have to, when we have this sum sign, we don't want to have to write out every term, plug in a 3, and plug in a 4, 5, 6, 7, 8, and write out. That's just extra work on ourselves. Does that make sense? But we could, and then do you see how we're looking at the same thing that we would if it was written out? Does that make sense? Because if you plug in a 3, what do we get? 28, right? Everybody? If we plug in 4, what do we get? If we plug in 5, what do we get? So do you see, and then we would just keep plugging it in until we plug in 8, and then we would add them up. So then, do you see how it's the same thing? It's just this one's written out, this one's like combined into one, like jam-packed, if that makes sense. Okay, so we're going to go backwards. So what we're going to do is say, okay, so we're finding a sum here, so that's why we do a sum sign. Sum means addition. And then how many terms are we summing up? We're going to have to do that thing again that we did in the first of the lesson. Let's figure out the distance between 5 and 38. So do 38 minus 5, everyone, hurry, quick. 33, and then we're not dividing by 1, though. That'd be moving in ones. We're moving in what? 3. So divided by 3 is 11. But that's saying take 5 and add 3 11 times. So we need to account for this term. So there's 12 terms. Does everybody understand? So we'd say n equals 1 through 12. We're summing up 12 terms. Does everybody understand 1 through 12? We're just going to use 1 through 12. And then we're going to write our explicit formula. Right, here's an explicit formula. For arithmetic, remember it's this. A sub 1, which is 5 plus n minus 1 times by the common difference, which was 3. And then you would simplify it real quick. So we distribute that in. So we're going to have 5 plus 3 and minus 3. So our explicit formula will be 3n plus 2. So our final answer would look like this. The sum of n equals 1 to 12. We're summing up 12 terms of 3n plus 2. Because this is what gives us these numbers. Everybody understands now? Okay, let's do one of the worksheets. Number 9. Here we go. So we'd say, okay, we can rewrite this as a summation notation because we know we're finding a sum. How many terms are we summing up? Let's find the distance. Negative 5 minus 10. Negative 15. Negative 5 minus 10 is negative 15. Well, that's working in ones, so aren't we subtracting 3 each time? Our common difference is negative 3. So divided by negative 3, which is, so 5. We're summing, so we subtracted 3 5 times to get to negative 5. So we're summing up 6 terms. We got to start with 10. So n equals 1 through 6. That means we're summing up 6 terms. Now we have to put in our explicit formula, which is a sub 1, which is 10, plus n minus 1 times by the common difference. Make sure you use the correct positive and negatives. 7 minus 10 was negative 3. Once again, our common difference was times by negative 3. I do want to see you simplify it, so let's plug that in. So that's negative 3n plus 3. So our final answer would be the sum of 1 through 6 terms of this formula, negative 3n plus 13. Because that's the formula that gives us these numbers. All good? We don't need another example. We still have 10 here though. 10 plus 3. Did I go too fast? Okay, do 8 through 13 go. So let's do, for example, we're going to do 23 together. So we're going to do number 23. It says find the sum, and it says it's okay, it's appropriate to use your calculator. Otherwise, if it didn't say that, you would do the formula. Correct, everybody? Okay, so here we go. So we have to have it in this format here. If you want to maybe hurry quickly write this down, it's going to help you when you get home to remember. Right there. So we're going to tell our calculator we want to find the sum of a sequence. Then we're going to have parentheses. We're going to put in the equation that generates the sequence. So in this one, we would put in x plus 3. Because look, n plus 3. So we'd put in x plus 3. Then you put in the variable you're using. Let's just use x. Comma, you put in your lower limit. So in this one, we're summing up the first through 15th term. So we put a 1 here. Comma, our upper limit is 15. So I'll show you how to get to all those buttons now. Go to your calculator. So you go to, you have to hit the, see, this is a statistic. You're going to go into the stat piece. You have to hit second stat. Second stat. We're going into the list. Then you're going to go over to math. Now you're going to go down to number 5 where it says find the sum. Now you have to get back into that stat key again. You have to hit second stat. Then go over, instead of over to math, now we're going over to operations. So number 5 is sequence. You see how, so we're telling our calculator we want to find the sum of a sequence. Hit enter. Is everybody with me? Where are you? Then you're out. And then you have to go second stat again. And then go over to operations down to sequence. Okay, so now let's type in the formula for number, what was it? 23. So you type in the formula x plus 3. So you type in x plus 3. Hit a comma. Right here's a comma. Look, comma. Now you put in the variable. Your guys' is because your calculator is more advanced. So it's giving you like how to do it. Like just read. What is it asking you to put in? The formula first? So just put the expression, put in x plus 3. Some people's calculators are going to be more up to date than this. But just put it in. It's asking you to do the same thing we're doing here. So then we're going to put in variable x, comma, our lower limit, which was 1, and our upper limit, which was, I believe, 15, right? Yeah, for this one it's 1. Remember, it's not always 1, right? But for this one, it's 1 to 15. Now we're going to hit enter. 165. It's just making it easier because your calculators are more advanced. But it should have put it in the same format here. Is everybody good? Yeah. And there's the sum. So you know how you guys were asking me, is my problem right for number 8 to 13? No. Okay, for 14 to 22, you can literally go in and check all your answers. So on the test, when I say do not use a calculator, you could still check your answer by your calculator. All good? Okay, so that's it. Finish the worksheet. Yeah.